Alright, example 4, we're going to sketch this polynomial. And we're going to really want to be able to do this not just with our graphing calculator, but finding the zeros so we know exactly what the graph should look like if we had to do it by hand. So to sketch this, what we're going to do first is talk about the zeros. We're going to factor out as much as we can. I'm going to pull out a 3x cubed on this problem. So we're left with x minus 4/3. So right away I can see that I have 4 possible zeros, but actually only 2 zeros that show up. We have the first part, 3x cubed equals 0. That's going to be 0 equals x with a multiplicity of 3. And we're also going to have, from the second part, 0 equals x minus 4/3. 4/3 equal x being our second 0. So on this one we have x to the 4th is our degree, so we know, let's talk about our end behavior. We know it's going to be something that looks like that because it's a positive, even graph with some weird stuff going on in the middle. And the weird stuff is what we don't really know about. And so that's what we can use the graphing calculator to help us out with. But know that we already know where the zeros are. 4/3 and at 0. So let's take a look at the graphing calculator and see what we get. I'll switch over to that. And y equals 3x to the 4th minus 4x cubed. My window still looks okay. Go ahead and graph this. And just what we imagined, some weird stuff is going on right at the bottom. So let me use a box zoom and we'll zoom in right around the origin and see what's going on down there. Okay, so right here is going to be 4/3. We know that that's one of our zeros from what we found before. So we have 4/3 right here. We know it crosses. And the other one, we know we're going through 0 because with an odd multiplicity, we're not going to touch. We're going to go through 0. So this one should just be turning over, not going up and down, even if we zoomed in. So even if I zoomed in right on the origin here to check out in more detail what's happening in here, you're going to see that it really is just flattening out and going through the point 0. So if I were to back this back out, let's go x from -2 to 2 and my y min from -1. Let's call it 4 just to give us a little room here to see. We can sketch that graph and we know exactly what our zeros are. Alright, you're up. Give it a shot on problem 75. Alright, problem 75. We'll go ahead and first thing we're going to do is apply the leading coefficient test. We know that this is a graph that's going to look something like this because it's a odd positive. Might be some weird things that go on in the middle. We don't know yet. Let's find the zeros of the polynomial. 0 equals, going to factor out an x, x squared minus 25. 0 equals x, there's 1. 0 equals x squared minus 25. So 25 equals x squared. So 5 plus or minus equals x. And there's 1, 2, 3 zeros, which is the most we can have. So we found them all. Alright, so plotting sufficient solution points and drawing a continuous curve through the points, we can graph this without actually using our graphing calculator. We know it has to look like this, our original shape, and we know where some zeros are. So let's go over here. We know that we have a 0 at 2, 3, 4, 5. We know that we have a 0 at 0, so it's going to cross there, and at +5. So we know 3 places where it crosses. We know it starts low, we know it finishes high, and so we need to draw a graph that goes through all of our zeros and follows the rules given by the leading coefficient test. So that's what your graph should look like, sketched out. Not going to be exactly accurate, but just a sketch of it with the general shape.